Okay. For this entire worksheet, we're using acute triangles. So the other thing you have to remember is the 3 trig ratios, and those are sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's why your teacher maybe at some point in geometry had you memorize SOHCAHTOA. I don't know if they did or not, or you might have heard that before. All of the things that we have today are going to involve one of those 3 angles. Keep in mind, if you're asked to find a length of a side, you're going to use the sine, cosine, or tangent function. If you're asked to find the angle, you're going to use a sine inverse, cosine inverse, tan inverse. Okay? So a lot of them, some of the harder things are drawing a picture. Are you familiar with the term angle of elevation? Have you heard of it before? Really? Angle of elevation is typically like an angle of sight, okay? And it's made with the ground. Well, we better write that down too. Here, we'll do a little thing here. So let's say I had an object up here, okay? And we're gonna assume that that object makes a right angle with the ground. There's 2 things you're going to hear. One of them is called the angle of elevation, and the angle of elevation is typically right there in the bottom corner. It's either made with eye level or with ground level. Another thing you're going to hear is something called the angle of depression. The angle of depression is this little angle up here. Okay, go back to geometry. Can somebody tell me what is true if these lines are parallel about the angle of elevation and the angle of depression? They're the same. So don't get caught up if I give you one or the other. They're the same thing. So if I give you the angle of depression, even though it's up here, if it makes more sense, put it down here for your triangle, or vice versa. Okay, so they're the same exact thing. All right. The length of a shadow of a tree is 130 feet when the angle of elevation to the sun is theta. Would you draw a tree? I am not an artist, so please do not judge. There's my tree. Can you tell it's a tree? If you don't even want to draw a tree, just draw a stick so you know that's where the tree is. I have an angle of elevation from the ground up to the top of the tree, so we're going to draw a triangle. Do you see how this would be a right triangle? Would you put a theta in the bottom? Down here, this is my length of my shadow. Okay, you're familiar with shadow, it's on the ground. So what should I put right here? 130 feet. Okay, you're also told for the first part, theta equals 25 in the first part. I want you to find the height of the tree. Would you put an X where you think the height of the tree would go? What part of the triangle? Did you put an X right here? Okay, so now our job is to figure out what the pieces are. So opposite, adjacent, hypotenuse. So what's the height of the tree? Opposite. Thank you, Nathaniel. It's opposite. What's the shadow in relationship to the angle? Adjacent. We got an O and an A. Which trig function involves that? Tangent. So then what we're going to do is we're going to set up a statement and use our calculator to solve. the tangent of the angle, what's the angle? What's the angle? 25 equals opposite over adjacent. What's in the opposite? This is why I had you put your calculator in degree mode, because we are going to use the tangent of 25 to solve for, oh sorry, Cole, you're Jolly Ranchering me? What should go there? 130. Thank you. Saw the confusion. I was like, why are they giving me that squid teeth? Look, 130. We're going to multiply through both sides by 130 and solve for x. All right, take your calculator out. What's 130 times the tangent of 25? $60.6 is what I get. You too? Okay. So I'm going to write 60.6 and I'm going to label my answer always feet. Okay, now scratch that. Let's say that I didn't know this angle of elevation. I'm going to call it theta. Let's just write a general statement. I think what you were telling me was that the tangent of this angle, the tangent of theta, equals x over 130. Isn't that, would you agree with that? No matter what, the tangent of the angle is going to be the height of the tree divided by 130. So let me show you how the inverse functions work. If you want to get the theta alone, what you do is you take the inverse of both sides. So what's the inverse of tangent? It's tangent inverse. So I'm going to go ahead and take the tangent inverse of this side. I'm going to also take, I'm going to squeeze it in up here, the tangent inverse of this side. The tangent inverse and the tangent function undo each other. So if tangent inverse undoes tangent, what would be left on this side then? What's the variable? These undo each other, so now what's left? Theta equals the tangent inverse of x over 130. Okay, so this is an equation that would find the angle for you. Would you use your new equation and use the tangent inverse button on your calculator and do D? Find the angle when the height of the tree is 100. Did you get like 37.6 degrees? Okay. Okay, does that make sense? We're just quiet and we have the noisy folks in the front are gone today. All right, here's what I'm going to do. We're going to not do all of these, and then there's a couple some are drawn for you. So like this picture goes with question 3. On this picture, just keep in mind that you have two, you might have to like work on both triangles to figure out the answer to that one, okay? I'm gonna set up number 2 for you. This is where I'm not a good drawer. This is my lighthouse. I know it's not pretty. I'm not gonna bother putting the light on it. Okay, so there are 2 ships offshore. So one ship is here, called ship A. And would you draw that down to that ship? And then there's another ship. Would you put it further out, ship B? Would you then try your best neatly to draw another line to ship B? Pretend those are straight. Okay. Okay. The angles of elevation, this is ship A, are 6.5 degrees. They say depression, but I'm going to use elevation because that's what makes sense for my triangle. And the other one is a little smaller, so it's 4 degrees. The question is, you're going to have to once again work on both triangles. Can you find the distance between A and B? So my selection for this, let's remember, is 350. You are going to be using tangent, but you're going to have to find both. You're going to have to do both triangles to find the distance between them. Okay? Because you have this, like find this piece, find this whole piece, and the difference between those would be the distance between the ships. Okay. Would you circle number 2 and number 3? We're going to cross off 5. I'm not going to talk about bearings yet. And we're going to cross off 4. Don't cross through the whole thing because I might use it later on. Ooh, 6 is a good one. And 7. And you can cross off 8. Okay, so there's 4 questions for you to do regarding sine, cosine, tangent, and their inverses.